job. But today, when I visited his laboratory, and he is in America now, and he has some position there, and also in Hungary. So what is the most important thing? That I visited his laboratory and I checked out what they are doing in AI. And I realized that this is really amazing system they built up for the Hungarian healthcare. The Hungarian ministry directly support them to build up an AI-based healthcare system in Hungary, and they can predict that who will have this kind of problem and this kind of problem and something like that. This man in this small village has to go to the doctor to check out because it seems that 5 years later he will have this problem. So this very, very strong prediction to save a lot of money in the healthcare system. And it is really surprisingly working well. I was really surprised. I checked the real system. I was there. And it's working. So you put your name and all data, all record and prediction of what things you will have, and you have to be checked out in 2 years, not to have the problem in 5 years, or something like that. Really amazing. So that's why I invited him to talk about. I don't know whether he's really talking about this point and what is the secret behind or not. I don't know. It's a political question, but I hope that he can give impression for you how deeply and it is a real application running. Okay, thank you very much. So he's in America, and that's why maybe video is better than online. And he said that he will be maybe a representative for questions
of the conference, and I'm really sorry that I cannot be with you in person at this moment, but my duties abroad just hold me from traveling back for the time of the conference. I would like to welcome the participants of the conference, and I'm really sorry that I cannot be with you in person at this moment, but my duties abroad just hold me from traveling back for the time of the conference. And I would like to talk about and I would like to share the screen before I start to talk about the AI-driven health optimization systems. And I would like to talk about 4 things. Number 1 is my journey with health data. And number 2 is I would like to introduce you the concept of the data colonialization and why we should be very careful in the case of health data. And also I would like to introduce you an AI product line and for diagnostic decision support in health, and also on database prediction capabilities. And I would like to conclude suggesting that all this, what we do with the data with my colleagues in the frame of the data-driven health division of the National Laboratory, all this leads to an AI-driven health optimization capability, a system capability. So let's start with my journey with data. And you have to know that between 2010 and 2014, I was working as Minister of State for Health in Hungary. And we started with very simple data analytics, for example, representing on heat maps the access times to various modalities of care. The red patches in the heat map of Hungary represent longer access times than we should tolerate it. We should have tolerated, and we could solve some of these red areas by reorganizing care. We also looked on the division of regional care responsibilities, and on the left side you see, for example, in the city of Pápa, the citizens had to travel for a certain modality of care to the Zalaegerszeg Hospital, and for another modality of care to the Veszprém Hospital. So we looked on, as you see on the right side of the slide, we looked on each and every locality, and we looked on each and every care responsibility and the regional division of labor in healthcare. And we also did graph analytics with our physicist colleagues on the patient movements in the system. And you see the cancer patient pathway here, the dots representing hospitals, the edges between the dots representing patient movements of at least 10 patients. So the insights provided by this very intuitive analytics led us to the centralization of cancer care. And what you see here is the increase in the number of cancerous liver metastasis operations in the country. The intervention numbers increased by 40%. And that means that before our interventions, these cancer metastases in the liver were operated in peripheral surgery units where they did not have sufficient diagnostics of care modalities. So we understood how easy it is to save lives with a very simple set of data, zip code, the code of disease, the financial code of disease, and also with the code of the institution carrying out the intervention. We did not stop there, and we also tested our methods in saving public money. What you see here is the list of invoices of the hospitals. We made them report because there was an issue, a sectoral policy issue of the indebtedness of hospitals. And you know, these were these very long tables of all the unpaid invoices of hospitals, and we did not necessarily understood the patterns. But when we put this data into a graph, the blue dots representing hospitals, the yellow dots representing the companies who are providing goods and services to hospitals, and the edges between them represent the indebtedness, and the broader the edge is, the larger the money they own to this certain procurer. So we understood, for example, the concentration of procurement to hospitals. We understood monopoly market formations, and we understood that hospital indebtedness is not necessarily a systemic issue, but it could be handled with targeted precision interventions. And the money we saved on those terms in 2011 and 12, that represented about $50 million per year. So we understood that from visualizing the data, we could gain precision insights and in structures. So this was my journey with data, and this is how we understood that if we take an agile approach, we can save lives and public money through data. You have to remember that data-driven health evolution and ontogenesis is happening now. China with its AI regulations, the US with its AI regulations, Europe with its data governance and AI regulations, they are contributing to develop a certain type of data-driven health species. And also the evolution, what we will be capable of do with our peaks if our systems develop, so to say, a bird, whether we would be able to take a worm out of the sand or crack nuts. That is happening now, and this is a very dynamically developing field. So data-driven health, ontogenesis, and evolution is happening now, and we have to take a strategic approach, because evolution shows an example. If you cross a beautiful horse with a donkey, the result is a mule that has that will not be able to produce the next generation. So we have to be very careful and very strategic and very professional when we are making our strategic decisions on health. We also have to remember, and this is the second warning I sent to you, is that data colonialization happens. Many times equipment providers give the natives some present, for example, an expensive diagnostic equipment, and then they teach the algorithm, and then the natives will find themselves that they sold the continent to the colonialists, because in 2 years they will take away the equipment and they can buy back the buy back the algorithm in the form of a license fee. But basically, this was done on a very low budget, on a clinical research budget, and on the body tissue of the publicly financed citizen care. And this is a good example. In Hungary, there was a very smart application, and Hungarian professionals, sort of, and Hungarian public money contributed to the clinical research that led to the FDA approval of a British-based algorithm. And we were proud that we would be able to outroll the solution that was helping stroke care on a national level, but we do not own any stakes in the company that by the FDA clearance could increase the corporate value. The first AI algorithm, and now we start the third topic of my presentation. The first algorithm, AI algorithm, that our colleagues brought to us was a mammography AI algorithm that in 2011, when the algorithm competed on a hackathon, beating MIT and Harvard students. The first algorithm was a mammography algorithm, and on this simple video, you saw how fast the algorithm puts the annotation on the suspicious area, and then the radiologist who does the diagnostics could check whether the decision support was properly done. So just simply think about the patient safety aspect of this. In Hungary, we have a 4I regulation, so 2 diagnostics experts should do the diagnosis of a mammography image, but you have scarcity of resources in radiologists, and there is a lot of waiting going on to have the diagnosis after the mammography, and also every human is destined to make mistakes. So if we could run this algorithm on picture archives, then we could see the false negatives, and the diagnostics could be assisted by the algorithm. And even though there's a lot of debate is going on around the trustworthiness of AI solutions, but from patient safety perspectives, we should start clinical trials in this, identifying false negatives and patient safety consideration as soon as possible. So we, sitting down with our data scientists and diagnostics colleagues, we decided that we will develop the next algorithm supporting the colorectal cancer screening. Because the colorectal cancer screening was introduced in Hungary in those times, and this is a long process from giving samples from colorectal colonoscopy and pathology examinations, and we recognize that we can support this process with AI, and we can support the increasing workload of pathologists by making their job faster, so having the diagnostics, the screening diagnostics faster. We created a platform where the pathologist could annotate the scanned colorectal cancer tissue, microscopic tissue samples, and we also identified the diagnostics criteria for colorectal cancer histology diagnosis. You see the annotation process on the right side of the slide, on the GIF, and you see the diagnostics categories on the right side. We then recognized that we put together an AI algorithm production line or assembly line, and today we are working on various modalities. What you see here on the upper left side, you see the tissue samples, the microscopic tissue samples. On the bottom left, you see the tissue scanner, and on the right-hand side, you see the AI response, the automated AI response to the diagnostic experts. we developed the cancer pointer platform, and we reached out to 8 pathology units in the country to participate in a national pilot. Once they have the response, then they can click on their tissue sample on the list, and they can zoom in and see the annotation, whether this is negative or positive, whether this is an inflammation or adenocarcinoma. And the diagnosis is supported by the AI automated annotation visualization for the pathologist. You see these sample units here, and you can see another example of how the annotations are put on the scanned pathology images. And you know, at present, it is not just colorectal cancer anymore. This is the first algorithm. We work on many other modalities, but our platform have proven that we could do it with any modality. And the concept is that once we are done with an algorithm, we are looking for, and we are working together with the ministry to have a national rollout of, at first, colorectal cancer, AI diagnostic support, but in the future, any modality of pattern recognition could be outrolled on a national level. So we made sort of a proof of concept that even one algorithm could be made as a system's capability if there's a system that is sort of capable of managing that optimization. And you know, this optimization is referring on, you see this dashboard, you can refer optimization on the work of professionals, the sensors themselves, the performance of both professionals and sensors, the volumes they produce, and also the patient safety considerations could be also taken into consideration. Yeah, so from one algorithm, we arrived to an assembly line, and we had the proof of concept we can do it on national scale. You know, after demonstrating you the proof of concept of how you can develop diagnostic decision support, AI-based diagnostic decision support as a system capability in the system in a healthcare system where the other parameters allow it to happen. As I mentioned, we started the pilot with 8 pathologies, and now there are 15 pathology units around the country that are joining to the pilot. We should jump to the data-based system optimization and data-based AI systems capability issues. In the Hungarian system, we have a joint national e-health platform, and the initiation of that was started during my administration back in 2011. And it became functional in 2017. But even before, because we have a one-payer system in the Hungarian healthcare, we have digital footprints of patients in the general practice, in the outpatient offices, in hospitals, pharmacies, all around the place. And if you compare these data sets, you see the digital twins. You see patient 1 having an unwanted outcome. And if we had the hypothesis that if we just do the analysis of these patient pathways, we could prevent patient 4 to have the same unwanted outcome, and we could intervene earlier. So thus optimizing the patient pathways. What you see here is these 2 windows representing my health window application, and this is by default to every citizen in Hungary. So we do not have data silos, but we have one joint national e-health platform. So digital twinning, the patient pathway analysis and optimization, it is there. You know, we see the footprints, we can do comorbidity analysis, we can see and understand new patterns in diagnostic or therapeutical developments. We could understand diseases more. Yes, we could look at the compliance to diabetes supervision protocol. On this chart, you see that out of the 9 compulsory lab examinations, there were 2 where more than 70% of the patients were not checked for that parameter in diabetes. And behind that there is a doctor and patient ID, so you can develop signaling systems to prevent the complications that emerge if you do not treat, do not follow, do not supervise diabetes conditions according to protocol. Yes, and from the footprints, you can predict morbidity. Simply from the consumption of pharmaceuticals, you can do that. But if you can put in higher definition data, you can analyze and you can find anomalies, as the mathematician colleagues try to do on our joint national database that came together during COVID times. So we are trying to do predictions on higher definition data sets. Yes, you can, from the footprints, you can also understand which age group or which comorbidity group was responding to which kind of COVID vaccination. So you can, from the footprints, you can even optimize vaccination protocols during pandemics. Yeah, so our work is concentrating on having new technologies, having new data streams from the incoming various data sets. And what we are working on today is combining all the available data sets, web results, the various images or vector diagrams of ECGs or CTGs, and we would like to develop methods for predictions. We would like to assist physicians and patients with decision support. And of course, we would like to use the optimization data for system management, business intelligence, patient pathway, and capacity management of the system. And we believe, and I think now we are just coming towards the conclusion, that AI-driven health optimization is a system capability in the Hungarian data sets. We have various health administration data. We have various patient records. We have various diagnostics images and diagnostics data. We have high definition research data. We are collaborating with cancer care institutions and cancer care researchers to have higher definition patient data, genomics, metabolomics, and all the innovative omics data sets. And we should not forget that more and more there is the generation of self-data, real-world data, whatever we call it. And if we integrate our solutions around the production line, we can develop system optimization or health optimization on a management level, let it be the sector or institutions or professional groups, optimization of the system, prediction of various conditions, and interventions built on those predictions. So optimizing the health status and the patient pathway at the same time. And also we can develop signaling systems to patient professionals and the various levels of management if an anomaly is emerging from the supervised data sets. And together with our colleagues, we put together this production line that leads towards it. As a data-rich country, we have to understand that time is going fast. We were rich in samples and data. Yes, we have a certain richness in smart analytics. We do not have as many data scientists as you can find here in the United States at the university that I am a senior fellow at this, Mustafa Rahman is senior fellow at this time. But we still have a competitive advantage. We have 100% probabilities in our very detailed data sets. And as I showed you, we have a capability to develop this AI-driven system optimization as a systems capability. I hope that my arguments and the use cases convinced you into that direction, and I wish you a rich debate, and I hope that we can collaborate in the future. Thank you very much for your attention.
Thank you very much for the presentation. So I think this is a good example for today, that he is a great scientist. He was a minister. He is top of a company. So this is almost everything we are looking for today. This is a really good combination. It's a very promising example for us. And also I have to say that his personality very good, very open for researchers, really warm welcome for any idea you have, really contact him. He is very open and friendly. Okay, so thank you very much again. So the next presentation is Professor András Hajdú. He received his MSc degree and PhD degree in mathematics and computer science at the University of Debrecen. Then he worked as a postdoctoral researcher at the University of Thessaloniki. Then he has been a full professor of the Debrecen University, and then as a career at the university, he was head of department, and he is the dean of the informatics. It's very important that I would like to emphasize that he is the leader of the local data science and visualization doctoral program and the founder of and director of the György Hajós Data Science Students College. And also he worked as a data scientist for the Hungarian Data Asset Agency between 2019 and 2022. And he served as an instructor for the Microsoft Learn for Education program, and he is certified by NVIDIA instructor program at University of Ambassador. And he has, the numbers are quite high, so he has a number of publications, citations, and age index. So András, please come. Okay, thank you very much for coming.
Thank you very much. Thank you very much for the warm introduction. So, Peter said everything, so I don't have to introduce myself. I am from the University of Debrecen, Faculty of Informatics, and this will be important from that respect that my speech will be about what to do in such an environment like our university. It's a very multidisciplinary university, so I'm the Faculty of Informatics, so I'm a mathematician and computer scientist guy, let's say so. So we have to do basically the technology part, but we have to do it in a very rich environment. So altogether, that much faculties we have at the University of Debrecen. Here you can see 13, but it's changing all the time, which is very important in this slide that you can see that many, many, many disciplines, basically everything. Technology, law, medicine, engineering, so a lot of stuff, indeed, even music. So, and it seems that AI will be everywhere, so we have to work in an environment. It's quite rare, also in Hungary, that there is so large number of domains at a university. So personally, me, for example, I'm working with these faculties for something like 30 years now. I know a lot of, I don't know, medical doctors, a lot of psychologists, and so on and so on. So it's really interesting how to work in such a domain. But I will try to show you that, I will show you some projects, let's say, so some results. So hopefully you will be able to see that what are the challenges in our case. I will, for example, focus on the clinical domain, engineering domain, also the agricultural domain. And I will also show you that what's happening when all these faculties, let's say, so join together and try to solve one very complex problem in the end. And besides the research part, let's say so, I will also show you that how to think about deployment, so how to make such solutions that are really works in the practice, and also that how is it possible to follow also from educational point of view this type of progress, which is very, very fast now as for AI everywhere. So let's start with the clinical domain. I have no time to go into the details. This project is very similar to the one the previous one, something with cytology, pathology. Here you can see otherwise it's cervical cancer. So this is how you can collect all these mass. This is uterus, something like, or vaginal wall otherwise. So you can collect all the samples, and basically the problem here is to try to find cancerous cells, if any, in this pap smear. And here you can see otherwise the whole system. Basically we have realized this system, so we are doing the final tests. So hopefully it will be possible to not really commercialize, more like to put it into the public health system in some sense in Hungary. But here you can see that indeed it's a large data set, so very big data, many cells, and of course very heavy implementation issues as well to be able to do it in relatively fast. So for example, faster than a human expert. So you have to do several cell detection problems, cell segmentation problems, and definitely in the end you have to do something with a classification or a final decision. What about the presence of cancer? It was otherwise an award-winning project, so hopefully it will be quite successful. Here you can see what were the challenges. For example, so the sample was coming like that from the medical school. So you can see here that also we have to remove these pencil annotations and so on. So it's tricky to work together, of course, with experts from other domains. I will skip these slides. Of course, I would be able to talk a lot about this system, but this is what I wanted to show you, that definitely our part is to do that one. So the technological part. For example, we are using ensemble-based systems, so we put together several AI algorithms to increase the accuracy. This is quite specific for us. Of course, it needs more resources again, because it takes more time, but basically, this is, for example, what we are doing for quite many years. We are also able to release annotated data sets, which is very important. We can also organize challenges based on the data set, of course. So this is, for example, what we are working now to release a new challenge where this solution can be provided also by other teams, and we provide the data sets, the annotated data sets for that. It's quite accurate otherwise, but it's under testing yet. This is also an ensemble-based technique, so you can create quite super architectures, you can put together AI architectures, and you can create large, indeed very large architectures in that sense. Of course, we are doing some mathematics. I just wanted to show you that, of course, this is our role in the whole university, so to try to solve basically the technological part. And definitely you need, I will come back to this image later, so we need specific hardware. So you have to be very cautious. I will show you at the agricultural slides that you have to be very cautious what type of hardware you are using. For example, there is also an HPC supercomputer network in Hungary, which sounds well, but unfortunately it's not so much optimized for these tasks yet. So if you want to do it quite fast and in a very much optimized stuff, you have to think about cloud solutions, or you have to do it on-premise. But then you will need some specific hardware, like for example this NVIDIA DGX server, which is dedicated to AI-related tasks. So when you want to use AI, you have to think about many aspects. And this is the final output, basically. So hopefully we'll be able to integrate the final output. Here you can see the cells, whether they are suspicious, and so on for cytologists. And also hopefully we'll be able to integrate the whole stuff in the manufacturer's user interface in the end. So the tissue scanners hopefully will also contain soon this tool for this specific task. This is some related publications. I don't just what I wanted to show you, that this is scientific data in the journal Scientific Data, but as I told you, this is important from that aspect, that we are able to provide publicly available data sets for the scientific community. Of course, there can be much more screening. We have in our practice for the last decades, retinal screening, skin cancer, and so on and so on. But I think will be very important in screening system to put now the large language models inside the loop, definitely. So this is also what we are working now to put together large language models also, and also image analysis, so everything basically. But as I would predict, I would think that the brain will be the large language models, and there will be many tools around these large language models. So this is definitely a very, very vivid field at the moment. Just some more examples from our practice, still the medical domain. This is, for example, the idea was here that if you have a model, this was for COVID, so to predict number of patients next day or something. This is a differential equation system otherwise, but it's possible that if you have an idea what the theoretical solution can be, that you provide a neural network, which is basically the same, so is able to approximate very well the theoretical model. Then you initialize with the theoretical model, and then you can save a lot of training time in this way, because you initialize not from the scratch, but you have an idea for the first solution. This is a theoretical model, and then you just refine it according to the data. So in this way, you are able to basically replace any type of theoretical approaches with neural networks, and you can speed up very much the training time, and definitely the neural network will give you a bit more accurate result than the theoretical models, because they are closed mathematical models, usually not that efficient in practice. Practice still a limit, but definitely, since usually these problems are chaotic, it's not possible to expect from a simple differential equation system that it will give you the solution exactly. Okay, some more ideas, video. This is pharmacology, small pet experiments. So what will happen to the rat or mouse if you apply different type of medicines? Again, video analysis. Also very important, the data set, just like in the previous lecture it was mentioned. So also University of Debrecen have a big data platform now, where basically we should offer the data to everyone for researchers, and also it's very difficult, of course, to open such a data set, GDPR and so on, so it's very, very difficult. I also always try to urge the university to make it as fast as possible, because if you are not opening this, sooner or later it will be obsolete, because others will solve that and the data won't be so valuable anymore. Also, generative AI is very fast now. There's a very, very, very fast development also for generative AI. This is one example when you put together a text and image. So basically, this is an annotation tool. So we would like to have the annotation of different lesions on CT images, or MRI, or X-ray, or anything. And here you have the CT image. Here you have a medical report, text description, and what you want to do to find basically the lesion on the image. And this is also to annotate data sets, to help annotating data sets. So basically, this is the idea, and this is the output, let's say so. And this can be, for example, be used for supervised learning again. But of course, here you have to put together the language model and the image model. Because, for example, it's here that there is a lesion somewhere in the top right corner with this size, and you have to be able to find that. So you can train the system with image data and medical data. Or of course you can do quite similarly, you can extract drug names from medical records, but now it's quite common at the moment. Okay, another field, engineering field. As I told you, I will try to see different type of challenges. For example, sensors, autonomous driving, what I can mention, industrial inspection, which is quite common challenge, basically vision-based, but as I told you, definitely should be large language models introduced here, or maintenance for vehicles to put on board AI solution to a bus. There are also bus companies running in Hungary. You can collect the data, driver behavior, or maintenance problems for the vehicle, or anything like that. So different sensors, of course. Or autonomous vehicle, we have a small car environment and also a large car, a normal car environment. The small car environment, in the small car environment, we can have such experiments, which is basically impossible to do in the large car experiment, for example, fog or very specific problematic situations. It's much easier to collect the data. Of course, it's very interesting to see what's the difference between the small scenario and the large scenario. And of course, you can also do the simulation. So the digital twin, let's say so, for the whole approach. This is the normal car, but this is the idea. Here you can see, for example, that generative AI again used to create smoke or fog or something like that. And you can do it in both scenarios, small and large. Small is much cheaper, of course. Or, of course, you can also create high-definition maps. This is our campus for autonomous driving. Here, for example, we use NVIDIA Omniverse. It's quite a good tool for that problem. So to use again this simulated world to collect training data. And if it's quite good, then we don't need the real data anymore. We can rely on the digital world. This is for sensors, for example, to catch radiation specific wavelengths, for example, for a, I don't know, leaking of a nuclear reactor or something like nuclear bomb stuff. And then you can put it on an area vehicle, a drone or aircraft or something. And then on FPGA, you can use this type of technique to try to find where is the location of the source of this radiation. And here, for example, you have to implement an FPGA AI-based solutions, neural networks, and so on. Agriculture, we have just launched it, I think now something like 1 or 2 years ago. So there was a large push, and there were some smart guys, let's say at the agriculture faculty, they said that yes, we have to start very much AI-based tools, using AI-based tools. Precision agriculture, for example, is quite unique at our university, that there are long-run experiments, so collecting the data for 40 years now. So it's quite a lot of data we have for agriculture. We focus on corn science. Food is very important, of course, so it's a very important field. And basically now the simple stuff is simple data analysis. You can put into a dashboard, you can do simple predictions, so basically simple neural network-based stuff. But as I told you, of course, we would like to advance. But already this is a large help for this domain. Correlation analysis for the different features. Also, we can provide very simple designer tools for those guys working at the agriculture faculty. Of course, they are not so good programmers, or they are not able to implement very easily. So it's Microsoft Azure-based designer stuff. But this is which is much more interesting, I guess. So we are creating such expert systems based on large language models. You put together a lot of stuff, images, and since they are developing very fast, I think it's very interesting. And also, but for example, here we dedicate it to corn science. So how we are able to increase finally the volume of the wheat in the end. You can use RAG models, rig models, many new models are released over the time, so it's very difficult, of course, to find which is the best one. You have to do it modularly, in a modular way to be able to change to a new model when they are released. Okay, this is, for example, it's much more complex problem. So, for example, this is a true problem. This is quite a large Hungarian agriculture company's problem. This is the input. Somehow this image is created. It's not so easy how it's created, but anyway, and the output should be like that. Homogeneous zones you have to be able to create as an output. And since we know that basically any type of input, we can create any type of output in the end with a suitable neural architecture, we can solve it, but it takes time and it takes effort and good ideas how to have this type of output, because it's far from being trivial. Okay, and what's happening when all the faculties, let's say, so try to put together and to create a large complex system? This is an urban monitoring system. Since Debrecen is rapidly developing as for industry, BMW arrived, CATL arrived, so battery factories, and many discussions, of course, for pollution-related issues. So the city said that, okay, we have to create an urban monitoring system to be safe, and then the university was asked, and basically we have something like, I don't know how much, but something like six to eight different work groups. Here you can see that we have to focus on air, water, soil, biodiversity, and also, of course, the IT guys who create the system. So we collect with sensors, and now it's under construction, this whole system. And again, the idea is that besides collecting the data from the sensors in a traditional way, let's say so, also we use large language models in the background. And here, for example, you can inject all the scientific literature. It's good for the researchers. We are also developing the public part, so how to inform the public. You have to be very safe, because if there is an information leaking, there can be a panic if something is released. So it's also very interesting that what type of models to use, how to filter the final information which can be released to the public. So this is, for example, a very interesting and very ambitious project now in the city. And we have to solve both the visualization part, but also, which is more interesting, the core, the brain of the whole system, which is AI-based again. Okay, and as I told you, so we have to think about to cover everything. So not only research, not only base models, but also to put it into deployment, to serve all the public demands. Perhaps there will be thousands of requests within minutes for such a system. So we have to solve basically also this part. And also I tried to explain it to the agriculture guys, for example, the company, so what type of hardware to buy. So I told them that everything should be kept in mind. So it's not only that we have the model and it's okay. No, we have to think about what will happen in the next years. So definitely you have to think about how you are able to, for example, optimize your model. There are tools for that, how to make smaller the model, more efficient, how to reach high-speed solutions. What about GPU, CPU? Does it need? Because it's an expensive game, of course. AI, it's not cheap, definitely. Scalability, parallelization, and so on and so on. So we also have to provide those tools, and we are able to do that. Also, what about the sensitivity of the data? Is it possible to go into the cloud, or definitely we need some kind of on-premise solutions? So again, you have to think about that, how to do that. For example, we have a nice relationship, good relationship with NVIDIA, also educational. So for example, at faculty level, we vote mainly for this architecture. Of course, we don't have that much money to buy too many, but still, it's a good platform. Also, we have several administration training, because it's also important to have a several administrator within the faculty, which is also not easy, because in Hungary, I don't know too many such guys who are able to administrate such hardware. And basically, this is, I think, my last slide. And this is personally, me is also involved in this stuff, because as Peter mentioned, we are NVIDIA lecturers too. But the main motivation is here that in this way, since the large technological companies, Google, NVIDIA, and so on, now they own the hardware. Usually they own the information, Baidu as well. So they own many such stuff which is not available for the universities at the moment. It seems that if we want to know also the knowledge, but also the hardware and the latest models, we have to have a very good cooperation with them. And for example, NVIDIA invested quite a lot of money and effort to have very good training workshops. So besides technological advancement, we are able to borrow their training materials to the regular courses at the university. So for example, I hopefully will go next month to NVIDIA headquarters, and I will be taught for 3 new workshops, courses for large language models. And these new technologies and new models were not available, I don't know, 6 months ago. So we have to be very, very focused, very fast, very challenging, of course, long life learning also for me, because I'm not so young, so it takes an effort, but still it's very important. And of course, if you are able to follow in that way, or the development, what's happening now, then we are able to provide it. For example, we have a project that we provide this type of trainings, also services for the different companies in different domains. So that's all from my side. We have many posters if you are interested in, so we are very happy to see you at our posters. So thank you very much for your attention.
So thank you very much for your wonderful presentation, but please don't run away. So, thank you very much.
Thanks.
Okay, so the reason why I invited András, because of the high quality work, and also because of the Debrecen University. Now you get a picture about Debrecen University, what they have, what they can do, what the capacity. And they have an exhibition, the whole corner, just to the next to the InnoHub corner. You can find the exhibition of the Debrecen University. Informatics and engineering, both, they are together. And also I would like to say that this corner is for the Budapest University of Technology and Economics, and you can find at least 2 departments with a lot of ideas and capability. Yeah. So please check out all of them. That's really important. Okay, the next presentation. by Professor Hugh Fullmoon. Sorry, my pronunciation. Please come here. You have all the slides and everything on the computer. Someone ran away of the... Okay, thank you very much. Yeah.
Testing. Good morning, everyone. So my sharing today is not really on the research, not on the science, and not on the technology, but more on the teaching and learning part, especially on the policy with regard to generative AI, undertaken by my institution here, INTI International University and Colleges. So the topic of my presentation today is AI in higher education from the perspective of Asian tertiary education. So as you can see here, I'm representing INTI, and perhaps that I shall start this presentation by giving an overview about what is INTI, where is INTI located, and then only I zoom in into what are the initiatives taken by the teaching team in regard to these generative AI and how our students being actually trained and also being monitored on the usage of this generative AI. So Malaysia, can I have a show of hand? How many of you here have been to Malaysia? Oh, not many. All right. So Malaysia is really very far away. For me to come here to Budapest, it takes me 17 hours flight. And there's no direct flight. I have to actually stop by at Turkey. Then only I can actually take the connecting flight to Budapest. But one thing, Malaysia is a very beautiful country. We have a total population of 34 million. And the size of our country is about 3 times the size of Hungary. So it's about 300,000 square kilometers. That is the size of Malaysia. And our population is 34 million. And it is very diverse. As you can see here, the Twin Tower, that's our iconic building. And if let's say that you happen to visit Malaysia, I'm sure that you want to go there. That is our shopping heaven. And in terms of the cultural diversity and multiracial, perhaps I will share with you that there are actually 3 main races or ethnics who actually who stay in the country. And we have the Malay, Chinese, and Indian. And basically, I am Malaysian Chinese. So that is actually how diverse it is. And because of that, the food is also very different, right? Yes, we have all types of cuisines that you can actually choose. So with regard to the institution that I come from, the INTI International University and Colleges, basically, we are just 38 years old. We started in 1986 as college. And then in year 2010, we have been upgraded to university. And somewhere in 2020, Hope Education Group acquired INTI Group of Colleges. And that is where that is like, for your information, Hope Education Group belongs to the Hope Group, which is actually a conglomerate in China. So in total, we have actually been in this education industry for 38 years plus, and we have produced 86,000 graduates. And so far in our campuses back in Malaysia, we have a total of 13,000 active students. And in total, we work along with 1,000 plus industry partners. And that's actually where that we have a total of 4 campuses. The university is actually located at Nilai, 20 minutes from Kuala Lumpur International Airport. And the three campuses that you can see here, they are colleges. So the university is the one which basically focus on the research and also teaching. And the colleges will actually very much focus on the teaching aspects. And we actually look at all these colleges. We work on the franchise degree program with our partners from UK, Australia, and also USA. So one thing that we are very proud about our institutions is that my institutions have this graduate employability rate of 99%. That means within 6 months upon graduation, there are 99% of them able to secure a job within 6 months. Another thing to actually mention here, 91% of our graduates are paid higher than the market average. So these are all the transfer programs that we have. In total, we have 350 plus partner universities. And the one that we work closely with will be UK, Australia, and USA. So on the left side of the screen, this will be our franchise partner. And our franchise partner is Swinburne University of Technology. We also have University of Hertfordshire, Sheffield Hallam for Art and Design, and we have Coventry University for our postgraduate programs. We have a total of 3,000 plus international students in our institutions, and in totality, there's about 100 plus nationalities. So, in QS ranking, we are ranked 516, and basically that we have actually achieved this title of #1 in Asia for inbound exchange students. This is our mobility program. So to everyone here, if let's say that you would like to collaborate with INTI, I welcome everyone. And these are the things that we can work on. We can work on this joint conference. We can work on joint research. We can even work on the student exchange as well as the mobility program, the study tour. So in total, there will be 10 fields of studies. We have business, we have art and design, we have hospitality, and we even have the traditional Chinese medicine. So in terms of level of studies, is actually for these degree preparation courses, we have certificate, foundation, and diploma, our bachelor degree, and for postgrad, we have the master and also our PhD. And for PhD programs, we even have the fully online DBA program. So now, AI. So basically, what is our initiative and also policy on AI? Back in Malaysia, I will say that I will share with you, Malaysian students love generative AI. Okay, not just tertiary students, but even primary school students. When this generative AI being rolled out, everyone is so excited with ChatGPT. The primary school students try to use ChatGPT to complete their homework. So that's where there is there is a need to have this policy to basically guide the students on the ethical usage of this generative AI. And at the same time, for our lecturers, of course, they also need to know that how this generative AI can be helpful in basically helping them in their teaching and learning. That's where we have this innovative teaching using generative AI. So our learning management system back there is Canvas, and we have these subscriptions to Turnitin. So Turnitin is our AI detector. We actually have an AI detector where all submissions by our students will go through this AI detector. And this will be the adoption timelines. We started in 2023 to communicate to academics on this generative AI, on the government principles and policy on this generative AI by MQA, Malaysian Qualifications Agency. And then we update our academic integrity policy. We start to train our academics on how to use generative AI in their teaching. And next, we have to tell our students what are the do's and don'ts in this generative AI, what are the situations they should use generative AI, and in what situations they have to be careful with this usage of generative AI. Then the next thing is to train them, to give them more workshops, and of course, the next is to continue to test and monitor how the whole thing works, whether we have a lot of students using it unethically or not, whether the integrity is there or not. Then the next one is that in June 2024, just a few months ago, we subscribed to the Turnitin AI detector, which I will show you how they will show the percentage of the these AI percentage. The next one is that by next year, we plan to basically roll out our institution-wide generative AI policy. So let's see the first one. That's where that we communicate to the academics. And over here, we mentioned that Malaysian Qualifications Agency basically say that generative AI is permissible. Means that students can use, lecturers can use, all right? But just that there is a need for ethical usage. And that's where that we start communicating with our academics. We basically guide them on how to use ChatGPT and AI generative tools for innovative teaching. And we also have the Turnitin Feedback Studio given by the representative from Turnitin on how to use the report, how to use the AI detections report, and the plagiarism similarity index. So we also have our lecturers who do peer-to-peer sharing session, whether AI is meant for collaboration or replacement, so that we keep our peers informed. And the second part of this PowerPoint slide will show that it's like how these lecturers mention that importance of basically emphasizing the importance of ethics when we actually use generative AI in this teaching and learning environment. So the next one is that we have lecturers who want to actually ensure that students do not rely too much on this generative AI. That's why the way the lecturer structure the assessment have to be creative, have to be different. And hence, this is where that they have this lecturer use CSR activities, so that there's no reason for students to use generative AI, no reason that you ask ChatGPT for anything. So that's where that we want them to involve in something that is more practical. And AI in education, there's some sharing here, that where there is like how AI can help in our teaching and learning, so this lecturer share. And we also invited someone from the Edge Hill Universities from UK to share about reshaping higher education learning and artificial intelligence. What do we need to know and do? So this sharing, not just internally, but we would like to get feedback, we would like to get some input from our peers from overseas. And this is where there is communications to students. So for students, we tell them what are the things that you can do with AI. And yes, they have to actually understand how AI tools work. Okay, please do not actually think that everything produced by generative AI means that in this case that ChatGPT is correct, all right? So it really depends on how we prompt the generative AI. So these are the things that we tell us, the guidelines on the usage of generative AI. And over here, we guide the students on how to do proper citation and referencing for these, if let's say they use generative AI, or then the second part is that to teach them how they can use generative AI, and the ethics part remain important. And the third part is that we still focus a lot on ethical considerations in AI. So in June 2024, just a few months back, we have the AI detector tool. We subscribe to Turnitin and we incorporate in our Canvas learning management system. And over here, I would like to show an example of the assignment brief of our lecturer. So we tell the students that what are allowed. We allow the students to use generative AI in idea development, in language and grammar improvement, in the drafting support. But we do not allow generative AI for content creation, because AI is meant to collaborate with humankind. AI is meant to help us, but AI is not meant for us that basically we sit there and then prompt them to do everything for us. But there is a need for humankind to actually have that, continue to have the critical thinking skills that we need for our graduates. this is the report. But one thing that I would like to mention, even though we subscribe to this report, Turnitin actually explicitly say that you can't rely on the percentage shown. It is not to say that 100% accurate. It doesn't mean someone with 61% detected as AI supported. It doesn't mean it is so. So there's a need for teaching team to understand this and to investigate, to sit down with the students to review the work. And if, let's say, it's really AI, then we will allow the students to resubmit. We do not give fail grade immediately once we see the report. This report is just a guide, just a reference that AI may be used here. And this one is actually where there is just a 10% report. They will highlight which are the paragraphs that most probably this part use generative AI tools. So we have just now initiative for lecturers, we have for students, and of course that we also do some collaborative work with universities from India, WOCSAN, and also University College London, that we basically organize this international conference on sustainable science and technology for tomorrow. And just yesterday, we have the Global HR Symposium. We believe that when it comes to generative AI implementation in university, we do not just work with lecturers and students, they are very important stakeholders, but at the same time, industry partners remain as an important stakeholder as well. So this is actually an example of how we work together on these, basically that knowledge on AI. So should you feel that there is actually where that you would like to collaborate with us, feel free to drop me an email, and thank you so much.
Thank you very much for your presentation. Let me give you a it's a famous Hungarian wine, but it's for ladies' wine. Okay, that was more or less presentation, and I'm very happy that we could invite professors, representations from different universities from all over the world. All of them are talking about AI, so I think this is the best way now to start collaboration. And I'm very happy that we have already started a collaboration, and we are just thinking about start a conference next year. It's called IBO. Finally, I like very much this idea, so I'm looking forward to start this, organizing this conference. So let me close the presentation session, and I think we have a chance now to have a photo, all of us. So if you go to the front of the building, Anna may coordinate us. I'm not so sure where we have to go, but somewhere here in front of the building, and we can have a photo of all of us. Okay? Thank you very much. This way, please. Follow Anna.